So here we have the first one. We are provided with the situation, and if you go through the description here, they say that this cylinder is immersed in the water, and the question is about the graph between R and the distance of the base of the cylinder from the line X. So this distance or depth is represented by the symbol D. You can call it H if you want to. And R here represents the reading on the Newton meter. The reading on the Newton meter is represented by the symbol R. Now the situation is, as long as the object is completely immersed in the liquid, is completely immersed in the fluid, the upthrust will remain the same. The upthrust would not change. Now, if I write down the expression for the for the forces, the force that would be there vertically downward, the easiest one, weight, and the force upward would be upthrust, and R is the tension. So the expression can be written as R plus U equals to W if it is moving with a constant speed. If it's in equilibrium, then the sum of the upward forces equal to the sum of downward forces. Then we can say R equals to W minus upthrust, and I can also say then R equals to weight mg minus upthrust, which is rho gv, density of fluid, volume of the object. V naught represents the volume of the object immersed in the liquid. As long as it's entirely in the liquid, upthrust would remain same. Weight would always be same, upthrust remains same, so the value of R would be constant. So the first part of the graph has to be a horizontal line because upthrust is constant as long as the object is entirely dipped in the fluid. So it cannot be A, it cannot be B, because the first portion has to be a constant value. If upthrust is same, then the value of R should also be same mathematically here. Now what is the situation? Let's say now the object is somewhere over here. It's no longer completely submerged in the fluid. It's no longer completely submerged in the water. It's something like this. Now in this case, we have to improvise this formula because the volume of the object in the water has now been changed. So I can write this expression like this: mg minus density of fluid rho g, and volume of the object I can write it as base area times the height of the height of the object, or the depth of the object which is submerged in the liquid. The portion, the depth or the height or the length of the portion that is submerged in the liquid. Now the situation is, as the object starts coming out of the surface of the water, the upthrust would decrease. It makes sense. The upthrust would decrease, and when it's completely out of the surface of the water, the upthrust would decrease to 0. So let me write down this thing. As object moves out of the surface of the water, because it's moving from x towards y, upthrust decreases, and when it's completely out, upthrust would be 0. So what does that mean? It means this portion, this quantity is being decreased, hence this thing would now increase. Upthrust was being decreased, so the value of r would now be increased. Or you can take a look at this expression also. The value of u is now being decreased, which means a smaller value is now being subtracted from w, hence the value of r should be greater. So the value of r should increase. But the question is, should the value of r increase linearly or exponentially, or should it increase at an increasing rate? Should it increase like this, or like this, or should it increase linearly? In order to answer that, we have to take a look at this expression, this one. So if I get rid of all the constants, then I can simply say r mg minus density of fluid g a h. You see, the relation between r and h is linear. It's a linear relation. There is no square, there's no square root in the expression. So the value of r would decrease as the value of h increases, but the value of r would increase linearly. So that's why D has problem in this portion, and hence C is the right answer. So the key takeaway is, as the object is submerged completely in the fluid, upthrust is constant. And when the object is coming out of the surface of the liquid, the value of upthrust increases. Hence, in this case, the value of r would decrease, but the upthrust increases linearly, and the value of r would decrease linearly. So there were a lot of concepts in this one. Now let's move on to the next one. I'll share the soft copy also, the PDF. I'm not going to raise anything from this one. Alright, so guys, here we have the next one. A boat is crossing a river in which the water is moving at a speed of 4 meters per second. Okay, in all that, whatever. What are the values of theta and v? Okay, in the diagram, v is the resultant velocity, 4 meters per second is the velocity of the water. The velocity of the boat in the still water is 6. So the diagram would look something like this. So let's say this is my first vector, which is 6 meters per second. Then this is my second vector, which is 4 meters per second. Then the resultant vector is always from the start towards the end. So this is your resultant vector. And the angle here, this one is 90. Now, first of all, we need to find the value of speed, v. V is the resultant velocity. You can clearly see that we have a right angle triangle here. So we can use the Pythagoras theorem to find this side. So I can say hypotenuse square equals to base square plus perpendicular square. So hypotenuse is 6, base is this one, and perpendicular is this one. So 36 minus 16, somebody must be having the calculator. So p square equals to 20, and the square root of 20 would be can't be 7, so it should be 4.5. So 4.5, 4.5 here, option B and D eliminated. Now all we gotta do is to find the angle theta. This is the angle theta. If we take a look at the diagram, this is the angle theta. Since all three sides are given, you can use any formula of trigonometry, sine, cos, tan. So if I could use sine theta equals to perpendicular over hypotenuse, then theta equals to sine inverse of 4 over 6 or 2 over 3. So if you hit it on the calculator, you'll be getting 42. So for this one, we have A as the right answer. Let's move on to the next one. This is a very important question, very repeated question. There's a very good chance you get a question like this, in which you have to draw the vector triangle by yourself. The speed of the aircraft in still air is 200 km per hour. The wind blows from west at a speed of 85. In which direction the pilot steered the aircraft in order to fly due north? I'll explain the first one in detail, but the second one, which is essentially the same, I'll draw the triangle directly. I'll fast forward the second one, but this one I'll explain in details. So the first thing that you need to look is how many vectors are there in this case, in the statement. How many vectors would be there? So we see we have three vectors here. The speed of the aircraft in still air, then the vector of the wind, the speed of the wind, and then in what direction the pilot steer the aircraft in order to fly due north. So he has to travel towards north. That has to be the resultant velocity. You need to draw the vector triangle by yourself. The question would be, which vector should you draw first? And the answer is the one for which you have magnitude plus direction given in the description. The one for which you have the magnitude and direction given in the description. So for example, the speed of the aircraft in still air is 200 km per hour. In what direction? We don't know. The wind blows from west means it blows towards east. Okay, wind is blowing from west means the wind is blowing towards east. This is what means by from west, means it's blowing from west, so the direction of the wind would be towards the east. So for the second vector, which is the speed of the wind, you're provided with the direction and the magnitude. So I'm going to draw this one first, whether you like it or not. I'll draw this one first, and the direction of this vector is over here towards east, and this is how much? 85 km per hour. And then we know that the resultant vector is the pilot has to steer the aircraft towards north, due north. So I need to now draw the resultant vector. So the resultant vector, for example, let me give you an example. This is my first vector, and let's say this is my second vector. the resultant vector always starts from the tail of the first towards the head of the last one. So I started the diagram from here. This is my starting point. So the resultant vector has to be placed at the starting point. And in what direction? Towards north. We don't know the magnitude of it, but this is the resultant vector and the direction is north. The resultant vector is placed at the start of the first one. That's why I placed it on the left side, not on the right side. You're not supposed to draw it over here. I mean, that would be a different thing that you can convert into parallelogram. You can also solve it this way, but the method that I'm following and I'm explaining, draw the resultant vector at the start of the first one. Now the second vector has to be necessarily in this direction. Because we know that that the resultant vector has to join the start point of the first vector to the ending point of the last vector. So usually you draw the first vector, then you draw this, sorry, this one is not the resultant. You draw the second vector and then you draw the resultant. But in this case, what we're doing is we draw the first vector and then we draw the resultant because we know the direction of the resultant, and then we join the second vector. And what is the magnitude of this one? The magnitude of this vector is 200. The speed of the aircraft 200. And now it makes sense also. You see, if we have the idea of the question, the wind is blowing from west, so the direction of the wind is over there, and the pilot wants to travel straight towards north. So what should be the direction of the airplane to compensate for the direction of wind? I mean, if he's flying straight up, then the wind would shift the direction of the airplane in this direction towards east. So what needs to be done is that in order to fly towards north, he needs to slightly bend in this direction, which is towards west of north. So he'll be bending slightly towards the west, and the wind coming from the west would cancel out that effect, and the airplane would travel straight towards north. And from this we can also know that he needs to travel west of north. We know from this method, and we know from this method also the direction of the speed of the aircraft or the velocity of the aircraft. It is west of north. This one is west of north, this direction. This is north, south, east, west. So he needs to steer west of north. I can cancel out option A, I can cancel out option B. We need to find the angle. Which angle? With respect to the north. The angle of the velocity with respect to the north. So angle of this vector with respect to north. plenty of ways. Those who are really good with mathematics, they don't even need to do that. You can draw north here, just like you guys do in the bearings. So this is north, and you need to find the angle of this one with respect to north, this angle theta. And if you take a close look, you'll notice this is also theta, alternate angles. You see a Z shape here. So these two are alternate angles. Now in order to find the angle theta, let's say this is the angle theta, this is perpendicular, and 200 is the hypotenuse. So sine theta equals to perpendicular over hypotenuse. Theta equals to sine inverse. Perpendicular is how much? 85 divided by 200. So you hit it on the calculator, you get 25.2. Okay, now I'll draw the diagram for the second one. How many vectors do we have? We have 3 vectors. In still air, a bird can fly at a speed of 10 meters per second. In what direction? We don't know. So forget about this one. The wind is blowing from east at a speed of 8 meters per second. Now this one is a good boy. We know the magnitude, we know the direction, so I can easily draw this one first. In this case, the wind blows from east, means the direction of the wind would be towards west. And the magnitude is 8 meters per second. Okay, so wind is blowing from the east, which in this case would be towards west. And the bird has to fly due north. So the bird has to fly due north, means the resultant has to be towards north. Where do we place the resultant? At the start of the diagram, at the tail of the first vector. So it would be like this. This one is the resultant over here. And where do we place the second one? We need to place the second one in such a way that we can complete the triangle. So that one would be someplace over here. Sorry, this one was single arrow. Only you represent the resultant one with the double arrows. So this one is the resultant, and this is in the still layer, it is 10 meters per second. Now this is the direction in which the bird must fly if it wants to fly towards north. So basically, you see, the wind would try to drift the bird towards the towards west. So the bird needs to fly into the wind. So the bird needs to fly into the wind, probably in this direction. So if the wind is over here and the bird is flying in this direction, the result of these two would enable the bird to fly due north. So in this case, the direction of the bird has to be east of north. You can see from here also, it is east of north. So west of north cancelled out. It has to be east of north. Now you need to find the angle of this vector with respect to north. So I can draw north here, just like we do in the bearings. So this angle needs to be found out. or alternatively this angle needs to be found out because these two are alternate angles, mathematically they are same. So sine theta equals to perpendicular over perpendicular over hypotenuse. So theta equals to sine inverse 8 over 10. Then you hit it on the calculator, you'll be getting 53. So the resultant force on a raindrop of mass m falling vertically with velocity v is given by the equation. We need to find the relation between terminal velocity v and mass. So I need to put v on y-axis and I need to put mass on x-axis. So what I can do is, well, I can rearrange the expression. So the expression can be written as kv square equals to mg minus f. I hope that makes sense. V square equals to mg minus f. Now since k is constant, d is constant, mass of the raindrop remains constant, so I can get rid of all the constants and the new expression can be written as v square is proportional to mass because everything else is constant. You know what I'm saying? Everything else is constant. Hence, you have the liberty to write this equation like this. Only because everything else is constant. Now, we don't need the square of terminal velocity on y-axis. Rather, we need only the terminal velocity on y-axis. So I'll be taking square root on both sides. So v is proportional to the square root of mass. V is proportional to the square root of mass. Now, you simply need to look for the graph that is something like this. So basically, we have V on y-axis, we have M on x-axis. So you need to plot this graph. You need to identify the shape of this graph from mathematics. Y is directly proportional to square root of x, which in this case, I can tell you the shape of this graph, y is directly proportional to square root of x, looks something like this. Alright guys, over to the next one. Full fat milk is made up of fat-free milk mixed with fat. So in this question, if you could read the statement, we have three things. We have fat, we have fat-free milk, and if we combine these two in a certain ratio, then what we get is full fat milk. Right, so this is a question that we have. So we have fat, we have two ingredients. If we combine these two, then we get this thing. We need to find the density of fat. So the density of fat would be mass of fat divided by volume of fat. So the density of fat would be mass of fat divided by the volume of fat. Now, what is the mass of fat? We don't know right now. We don't know. What is the volume of fat? We don't know directly, but we see it contains 4% fat by volume. Full fat milk, which has a volume of this one, 4% of that volume comes from the fat. So this volume is, if I could write here, the volume of this thing is how much? 1.000 into 10 to the power minus 3, this much. This is the volume of the final product, but 4% of that volume comes from fat, and inductively 96% of the volume would come from fat-free milk. Now, what is 4% of this? We can find the volume of fat by finding 4% of this. 4% of this value. So how do we find 4 divided by 100 times 1 into 10 to the power minus 3, which is 4 into 10 to the power minus 5. So we know this value now, that the volume of this one is 4 into 10 to the power minus 5. Now, what is the mass of the fat? We don't know the mass of the fat. This is a thing that needs to be found out. So once again, we have three things. We have fat, then we combine fat with fat-free milk, and the final product that we get is this one, full fat milk. And what is the mass of this final product? The mass of this final product is 1.035 kilograms. What is the mass of this one? We don't know, but we can find the mass of this, the second ingredient. Then we can subtract the mass of the second ingredient from the total mass, and we can find the mass of the fat. Now, how do we find the mass of the second ingredient? How do we find the mass of fat-free milk? That mass equals to density times volume. We know the density of this. What is the density? 1.040 times 10 to the power 3. What is the volume of this? We don't know directly, but like I said, it's 96% of the total volume. So we can find here 96% of the total volume, or you could have subtracted also, but let's find 96% of the total volume. Total volume is once again this one, the volume of the final product. By which we can get 9.6 into 10 to the power minus 4. So mass, we can use this value of volume here. So mass equals to density times volume. So what we get is 0.9984. So the mass of the full fat milk was 1.035. So the mass of the full fat milk, sorry, the mass of the fat in this case would be the total mass minus the mass of the fat free milk, which in this case would be 0.0366. Now finally we have the mass of the fat, 0.0366. Okay, so all the calculation was basically done in order to find the mass of the fat. Everything else was given pretty much um, directly, but the mass of the fat was calculated after all this calculation. Now we divide these two on the calculator, and what we get is 915, which can also be written as option B in 3SF. So the most advanced questions from this topic could look something like this. Let's move on to the next one. Okay, this is where I'm going to skip these two for a moment. Let's take a look at this one. We need to find the magnitude of the frictional force. So in this question, they accelerate, so we need to use F resultant equals to ma, and we have to apply this expression first for the block 0.20 and then for the block 0.50. So tension would be here. For this one, the tension would be upward. The friction force between the surface and the block would be against the direction of motion, and let's say this is the direction of the acceleration. This one would accelerate downward and the upper one would accelerate to the right side. I'm going to apply F resultant equals to ma for the first one. Let me call it object A, and let me call the second one object B. F resultant equals to ma. Okay, F resultant equals to ma for the object A. What is the resultant force? T minus F or F minus T? It would be T minus F because it's accelerating to the right side, equals to ma. First equation done. Let me write the expression F resultant equals to ma for the second object, for the object B. So the force vertically downward would be weight, mg, weight minus tension equals to ma. F resultant equals to ma. This is basically F resultant equals to ma. How do we know it's is W minus T, not T minus W? Because it's accelerating downward. So in this case, let us insert the values now. W is 0.50 times 9.81 minus tension as it is. We don't know the value of tension. We'll try to cancel tension with these two equations, equals to mass which is 0.50 times A. Acceleration is also given, but I'll take acceleration common afterwards. For the first one, it would be t minus f equals to 0.20 times a. So if someone could give me 0.50 times 9.81, 4.90, okay. 4.90 minus t equals to 0.50a. I'm going to write this expression underneath the first one, and I'll write it smartly. Instead of writing 4.9 minus t, I can write it as minus t plus 4.9 equals to 0.50a. Now I can add these two equations. So plus t minus t would be cancelled out. And if I add these two terms, it would be 4.9 minus f. And if I add the right sides, it would be 0.70a. Now we can also say f equals to, if I shift f on the right side, it would be 4.9 minus 0.70a. A in this case is 2 meter per second square. This is the value of a. So the friction would be 4.9 minus, I think it would be 1.4. So would be exactly 3.5. So here we have the next one. A ball is suspended by a light string and weighs 0.15. We need to find the force on the ball from the airflow. We need to find this force. The tension would be here. The weight would be exactly vertically downward 0.15. And if it is being suspended and the object is in equilibrium, which is mentioned over here, then the forces in any direction, the resultant force should be 0. So I can split the force of tension into components. So the two components would look something like this. So if this is angle theta, this one would also be angle theta, which is 30. So this component would be t cos 30, and this one would be t sin 30. So basically the object is in equilibrium because t cos theta equals to the weight, and the other two forces, airflow, is being cancelled by the component t sin theta. So I need to find this thing, airflow equals to t sin theta, but we don't have the value of t. So like I said, airflow equals to t sin theta, but first we need to find the value of t. I can use the second equation here, t cos theta equals to w. So t equals to w, which is 0.15 divided by cos theta, cos 30. Cos 30, by the way, is 0.866. So you divide it on the calculator. T would be 0.17. Then you can use the same value here, 0.17 times sine 30, which is 0.5. So it would be 0.087. Electricity, I'm skipping for a moment. Then we have the next one. It's not really advanced question, but the thing is, many of the students forget this one, how to subtract the vectors. I mean, you can also rearrange and convert it into addition of two vectors, but the very expression r equals to q minus p, you can also write it as r equals to q plus the negative of the vector p. What does that mean? same magnitude of p but in the opposite direction. And then you add these two vectors, q and minus p. So draw the first one. Let's say q is the first one. At the end of the first one, draw the second, which is the second one, minus p. So I started from here and I'm ending over here. How do I draw the resultant? From the starting point towards the ending point, which in this case would look something like this. Option C. Then we move on to the next one. A uniform bar of, okay, this is a uniform bar and it is in equilibrium, means we can safely apply the principle of moment. We need to find the ratio of Rx to Ry. You see, we have two pivots. This is a double pivot problem. In this one, we have to assume that X is the pivot, we make an expression. Then we assume Y is the pivot, we make the other expression. Then we solve them. So let's suppose Y is the pivot. When Y is the pivot. So let us apply the principle of moment. Y is the pivot. So this force would not be used because it passes through the pivot. These two forces would be used. So W times the length between these two. It's a uniform beam. So L by 2. The total length is L. So it would be half of the length. The second force would be Rx times what is the perpendicular distance of that force from that pivot. The total is L. On the left side you have L by 6. So the leftover is 5L by 6. You can subtract it on the calculator. You can use fraction and write this one. 1 minus 5 over 6. 1 minus 1 over 6. You'll be getting 5 over 6. So this is the first expression. Okay. Now let us assume that X is pivot. If X is a pivot, if this is a pivot, then this force would not produce any moment. Hence, the expression would be W times what is the perpendicular distance between these, between the pivot and W. I mean, up till here we have L by 2. So 1 by 2 minus 1 by 6. 1 by 2 minus 1 by 6. So we'll be getting L by 3. This distance would be L by 3. You can do it on the calculator. Equals the other force Ry, and the perpendicular distance of that force from the pivot is once again 5L by 6. Now I'll make Rx subject in the first one. You see, length and length would be cancelled out. So if I make RL the subject, it would be 0.5 times 6 divided by times W divided by 5. So 0.5 times 6 is basically 3. So 3W divided by 5. Now let's talk about the right side. Length cancelled out. Ry equals to 6W divided by 5 times 3. Then you can also write it as 2W divided by 5. We need to find the ratio of Rx to Ry. So what is Rx? The simplified form of Rx was 3W by 5 divided by the other thing. So I'll have to use keep change flick. Need to take the reciprocal. So you see 5 and 5 would be cancelled out. W and W would be cancelled out. You'll be left with 3 by 2. So for this one, we have 2 containers and everything. The object is same. First time it is dipped in the water, the upthrust acts on it, and luckily it's completely dipped in the water, so upthrust is uniform in both of them. But the value of upthrust would be different because the density of the fluid is different for both of them. Now let me write down the expression for the equation. See, I'm going to label the forces for the first one. There would be force on the spring balance, which is represented by the symbol force on the Newton meter P. Okay, let's call this force P, and the other one is labeled as Q, this force on the spring balance. Weight would be vertically downward, weight would be vertically downward. We're not going to call it W1 W2 because it's essentially the same block, so it has the same weight. Upthrust here would be U, and upthrust for this one would be U. Upthrust would be different, by the way, for both of them. You can call it U1 and U2. Okay, upthrust of the water, this would be the upthrust of the water, and this would be upthrust of the oil. Now the equation for the first one would be, if we can form the equation of the first one, for the second one equation would be identical. The only difference would be the value of upthrust. If it is so the expression would be P upward forces equal the downward forces P plus Q equals to P plus upthrust of the water equals to W, the weight of the block. Upward forces, sum of the upward forces equals to the sum of the downward forces. Thereby upthrust equals to W minus P. So upthrust, density of water times G times the volume of the object equals to W minus P. Likewise, you can even start from the scratch for the second object, or you can directly write the expression for the second object considering this equation. So for the second object, oil, it would be density of oil times G, volume of object would be same, equals to weight is same, minus the force on the spring balance. In this case is not P, rather it is Q. I'm going to make density of oil the subject here because we need to find the ratio of density of oil and density of water. So if I make density of oil the subject, it would be W minus Q divided by G V naught. Likewise, if you make density of water the subject here, it would be W minus P divided by G V naught. And what are we supposed to find? Density of oil divided by density of water. So the first expression, this is the density of oil, divided by the second one, which I'm going to take the reciprocal. GV naught divided by W minus P. And you see clearly that this stuff would be cancelled out. And what are you left with? W minus Q divided by W minus P. So in this one, we are supposed to find the Young modulus of the instrument, of the chord. For Young modulus, we have the formula Young modulus equals to FL naught over AX. We also have the formula Young modulus equals to stress over strain, because the data now we have is with the given data, this formula is more compatible. Now we need to find the value of force first. So if this is weight and the tension would be T, from there, using the principles of Newton's first law, we can find the value of tension. So tension would be found if we can resolve this one into components, if we can resolve T into components. So the component of T, one component would be over here, the other one would be over here. Likewise for the second one, the tension on the string on the right side, one component would be over here, the second one would be over here, but these two would be cancelled out, so we don't even need these two. So one at the top would be T cos 30. You see, this angle is 30 from the middle. And for the second one, it would also be T cos 30, because from the middle one, the angle would be 30. Actually, these two vectors are on the same line, but I'm drawing it differently so you can clearly see these two. Now T cos 30 plus T cos 30 equals to the weight of the blocks placed at the bottom. So T cos 30 plus T cos 30. How much is that? T cos 30 plus T cos 30. That equals to the weight of the blocks placed at the bottom, which equals to mg. Now 2t cos theta equals to m into 9.81. I need the value of t quickly. If someone could help me with this one. Okay, I can use it as 2.3 Newton. So the force is 2.3. The original length is how much? The unstretched length is 16 centimeter. That's what they say, 16 centimeters. So which is 0.16 divided by the cross sectional area is, luckily it's given in meter square, 10 to the power minus 6, and the extension is how much? So the new length, extension is basically x is the new length minus the original length. Extension equals to the new length minus the original length. What is new length? 8 centimeter here, 8 centimeter here, 8 centimeter here, 24. The original was 16, so the extension is 8. Centimeter to meters would be 0.08. So what is the magnitude of the change in momentum of the snooker ball? Okay, so the change in momentum is basically the final momentum minus the initial momentum. Final momentum minus the initial momentum. So this is your final momentum minus this is your initial. I mean, technically it's not the momentum, it's the velocity, but the momentum is indeed in the direction of velocity. If we can multiply the mass and speed, we'll get the momentum. We'll multiply mass and speed, we'll get the momentum. So for the first one, the momentum would be 0.20 times 0.40, and for this final momentum it would be 0.20 times 0.30. Now, change in momentum is final momentum minus initial momentum. So you need to subtract the two vectors. Now, they are not in the same direction and not even in the opposite direction. So you cannot simply add or subtract. This is a tricky part here. The two vectors of momentum are not in the same direction and they are not even in the opposite direction. So simple addition and subtraction cannot be done here. You need to do vector addition or subtraction. So there's basically is vector addition. Even if you have to subtract the vectors, is basically the addition of vector. So we'll have to, I can write PF minus PI as PF, final momentum, plus the negative of the initial momentum. So this is my final momentum. The initial momentum was to the right side, but the negative of that one would be to the left side. So this is final momentum. And my drawing starts from here. This is the my negative of initial. And now the final vector, the resultant vector would be in this direction. This is the change in momentum. If they ask you to find the angle and all that, that's why I've drawn the triangle. They can ask you to find the angle with respect to north or with respect to the x-axis, anything. But in this case, we need to find the magnitude. So 0.20. 0.2 times 0.4. This one would be 0.08. So this side is 0.08. And the second one is 0.3 times 0.2. So it would be 0.06, I think. Yeah, 0.06. You need to find this one. So which is basically hypotenuse. So this equals to square of this plus the square of the second, and then you can take the square root of all of it. So I'll put it on calculator as it is. I get 0.1 into SF would be 0.10.